All right, today we're going to pull back the curtain on one of the most important ideas in all of AI, supervised learning. It really all comes down to a simple but incredibly powerful idea of how we teach machines to think just by showing them a bunch of examples. So, let's dive in.
You know, this analogy right here is the key to the whole thing. At its absolute core, supervised learning is just like giving a computer a massive stack of digital flashcards. You give it thousands, maybe millions of examples where you've already provided the correct answers. And after seeing enough of them, it starts to figure out the patterns all on its own. So here's the slightly more formal way to think about it. That word supervised, it really just means the data has been labeled. It's like the algorithm gets to study for a test with the answer key right next to it. The entire goal, the whole reason we do this, is to get the machine so good at understanding the connection between the questions and the answers that it can make really accurate predictions on new problems it has never ever seen before. Now, this one powerful technique is basically used to do two main types of jobs. And depending on what you're trying to predict, you're going to use one of two different approaches, either something called classification or something called regression.
And honestly, the difference is pretty simple. Classification is all about sorting things into buckets or categories. Is this email spam or not spam? Is this a picture of a cat or a dog? It's a choice between distinct options. Regression, on the other hand, is all about predicting a specific number from a whole range of possibilities, like what is the exact price of this house, or what will the temperature be tomorrow afternoon.
The crazy thing is, you are already using classification every single day. That spam filter in your inbox? Yep, that's a classification model that learned from millions of emails that humans labeled as spam or not spam. But it gets way more serious, too. Doctors are using this to help spot diseases in scans, and your phone's camera uses it to recognize your friends' faces in photos.
And it's the same story for regression. You're surrounded by it. Zillow's famous Zestimates, that is a perfect example. They feed a model tons of data about past home sales, the square footage, location, number of bedrooms, and what they finally sold for. That lets the model predict a price for a brand new listing. It's the exact same idea behind forecasting how many inches of rain we'll get or trying to predict where the stock market is headed.
So how does a data scientist actually do all this? Well, they have a kind of digital toolkit, and it's filled with different algorithms. Each one is a specialized tool that's suited for a slightly different kind of problem.
This is the natural next question, right? If supervised learning is the overall game plan, what are the actual plays you can run? So let's take a quick peek at some of the most common tools in the toolkit without getting totally lost in the technical jargon. All right, let's look at some of the heavy hitters. You've got linear regression. That's the classic workhorse for predicting numbers. It's basically just finding the best fitting straight line through your data points. Its cousin, logistic regression, is for sorting things into one of two groups, like a simple yes or no. But then you get to the really cool stuff. A random forest, for example, is amazing. It doesn't just build one decision tree, it builds hundreds of them, and then makes them all vote on the right answer. It's like crowdsourcing a prediction, and it's way more accurate. And a support vector machine is just brilliant at finding the absolute cleanest, sharpest line to divide different groups of data.
Out of all the algorithms, decision trees are maybe the easiest to understand because they work just like we think, like a flowchart. It just asks a series of simple yes or no questions to get to the end. For a house price, it might ask, is the house bigger than 2,000 square feet? Yes. Okay. Does it have more than 3 bedrooms? No. All right. Then the predicted price is X. It's just beautifully simple.
Okay, but as amazing as all this sounds, it's not magic. Not even close. In the real world, getting these models to work well means you have to overcome some pretty big hurdles.
And this is the question every good data scientist is always asking, right? If you can just throw labeled data at a machine and get answers, what's stopping us from solving literally every problem on Earth? Well, the catch, almost every single time, comes down to the data itself.
Here are the 3 big ones you'll always hear about. First, getting good, clean, accurately labeled data is incredibly difficult, and it costs a lot of money. Just imagine paying expert radiologists to label hundreds of thousands of medical scans. That is a huge undertaking. Then you have these 2 other killers, overfitting and data bias, which can just completely wreck your model.
Oh, I love this analogy. It just makes the idea of overfitting perfectly clear. An overfit model has basically just memorized the answer key for the training data. It's fantastic at answering questions it's already seen before. But the second you give it a new problem, one that's even slightly different, it completely falls apart because it never actually learned the concepts underneath.
So look,
Despite all those challenges, when supervised learning is done right, it is truly transformative. So let's just look at a few examples of its massive real-world impact.
In healthcare, for instance, these models are being trained on thousands of scans that have been labeled by expert doctors as either a tumor or no tumor. And they can learn to spot these incredibly subtle patterns that even a human eye might miss, acting as a vital second opinion for doctors.
And think about finance. Every single time you swipe your credit card, a supervised learning model is analyzing that transaction in real time. It's been trained on millions and millions of past transactions that were labeled fraud or not fraud, and that allows it to flag something suspicious in milliseconds to protect your account.
And then there's the stuff we see every single day. The recommendation engines on Netflix and Amazon. That is supervised learning at a massive scale. They train models on your personal history to predict what you're going to want to watch or buy next. It's basically a giant classification problem trying to give a thumbs up or a thumbs down to everything in their catalog, just for you.
And it's not just consumer tech. In the industrial world, companies are using sensor data from their heavy machinery to predict when a critical part is about to fail. By training a model on data from past breakdowns, they can schedule maintenance before a catastrophic failure happens, saving millions of dollars. So, if any of this stuff sparks your curiosity, here's some key advice. First, start simple. Really get a handle on the fundamentals before you jump to the fancy, complex stuff. Second, and this is the big one, obsess over your data. Understanding your data deeply will get you better results than any complex algorithm. And finally, the golden rule, always test your model on fresh data that it has never seen before. It's the only real way to know if it actually learned or if it just memorized.
In the end, it all comes back to this one simple truth. Supervised learning is all about teaching by example. And the most powerful, most complex algorithm in the entire world can't save you if you're teaching it with bad examples. The quality, the accuracy, and the fairness of your labeled data, that will always be the number one thing that determines your success. So the real question is, what problem would you want to solve if you had the perfect set of examples?